Good morning, dear students. Today we will discuss about a topic which is concave mirror, concave lens, convex mirror and convex lens. Speaking about the concave mirror, we'll start from the picture. This is the concave mirror. It is an opaque object that light cannot pass through it. When a beam of light falls on it, it cannot pass to the other surface. Instead of that, the beam will reflect back in the same medium, same side. And in concave lens, this is the concave lens, it is a transparent object. If a beam of light falls on it, it will pass through it and diverge in the other directions. Now we'll go to the convex mirror. The convex mirror is also an opaque object. The light cannot pass through it. If a beam of light falls on its surface, then it will reflect back on the same surface. In convex lens, as it is a transparent object, if a beam of light falls on it, it will pass through it and diverge in the other surface. So, to explain you all about this, we will take an animation video in which I will try to explain you in animation, making the light rays fall on the surfaces. Difference between convex, concave mirror and lenses. Concave mirror is an opaque object. Light do not pass from one side to another. When light beams comes in contact with the mirror, the light rays converge at one point and focus the beams. But the concave lens is a transparent object. When light falls on it, it passes from one side to another. When an object is kept in front of a concave mirror at a distance, the beam of light reflects back on the same side and forms a real and inverted image. But when light beams falls on one side of a concave mirror, it diverges the beam on the other side but does not focus the beams, instead make them apart. Now, when an object is kept in front of a concave mirror at a distance, then the beam of light reflects back on the same side and forms a real and inverted image. As concave mirror is an opaque object, light cannot pass, so it forms an image on the same side, which is a real image. We feels like the image is formed behind the mirror, but it is not true. Image is formed in front of the object, not behind the glass. It's an imagination. If the object is kept near the concave mirror, then it reflects back on the same side of the mirror, as it is an opaque object. But it will be a virtual image. We will feel it as a real image, but it's again not true. Now, speaking about the concave lenses. When beam of light falls on the concave lens, then it will diverge on the other side, but then the focus them makes them apart. In case of concave lenses, when light beams falls on the concave lenses, then it passes out to the other side, but an imaginary image is formed in front of the object, which is not real but virtual and small. It does not matter at what distance we keep the object, we will always get a virtual image, as the beam near past the lens. Still, the imaginary image is formed on the same side, so it is erect and is a virtual image, not real. Speaking about convex mirror, it is an opaque object and light cannot pass through it. And when light rays falls on a convex mirror, it reflects back to the same side. But convex lens is a transparent object and light can pass through it. When light rays falls on the convex mirror, then the beams diverge. But in convex lens, light beams passes to the other side and converge, focusing at a particular point. Now, when an object is kept in front of a convex mirror, then the light beams will reflect at the same side, forming an image behind the mirror, which will be always erect and virtual. It does not matter either we keep the image at close or distant place, but the image formed is always virtual, erect, not real. Since light beam cannot pass through a convex mirror, so we will always get an imaginary image, not real image, and it is opaque. But if in case of convex lens, if you keep an object in front of it and close to it, then it forms an erect image, but virtual image. If we keep the object at a distance in front of the lens, then we will get an inverted image. So here I am showing the formation of inverted image, which is kept at a distance. Now this will be a inverted and image. So hope students you have understood. Thank you so much for completing the video.